Okay, so you got donuts today? D cubed? $1.40 per donut? Are you serious? Don't you know there's a pandemic going on? I mean, yeah, you're so adorable and everything, but $1.40? I'm not rich, you know. Money doesn't grow on trees. I'm sorry, but I just can't afford $1.40. Thanks. Hey, D Cube Donuts, how's it going today? Oh, you got donuts $1 per donut? You know what, at that price, I think I'll take 2. You take debit cards, right? Yo, D Cube Donuts, what's going on? Ah, you got donuts for 80 cents per donut? I think I'll take 3 at that price. That's a great price. Wow. Hey, D Cube Donut, you have free donuts today? Are they day-old donuts? Wow. I think, you know, for free, I think I'll take 7 because, you know, I don't want to get a bellyache. Wow.
Well, I need to make these donuts, but they're only offering me 17 cents per donut. There's no way I can make donuts for 17 cents a piece. Forget that. Well, I'm looking at the numbers, and if they pay me 80 cents per donut, I think I can afford to bake 3 donuts at 80 cents per donut. Yep, that should work. $1.92 per donut. They're going to pay me $1.92 per donut? Well, then I'm willing to make 5 donuts.
Donuts. Hi, welcome back. So we just saw the D Cube Donut Shop, and we saw the donut shop from the perspective of the customer and also from the perspective of the donut maker, who is also here joining us for the rest of class today. So today we're going to be talking about section 13.4, which is consumer and producer surplus. And so we're going to continue with the example that we saw the sort of trailer for at the beginning of class. And we're going to talk about, at a donut shop, a customer is willing to buy X donuts when the price per donut is P equals 1.4 minus 0.2X dollars per donut. Okay, so let's start by graphing this function so we can kind of talk about what's happening. Okay, so we are going to graph 1.4 minus 0.2x, and we're going to graph this on the interval from x going from 0 to 8. I know that's a good choice because I've looked at this graph already. And then I'm going to look at zoom, and I'm going to go down to zoom fit and hit enter. Okay, so we get this picture. Now, our x values that we have here are 1, 2, 3, 4, 5, 6, 7, 8. And then we have y values here. This is y equals 1. And if I type in trace and type in an x value of 0, our y output is 1.4. Okay, so we're now ready to draw this picture on the board. All right, so the picture that we are drawing has on the x-axis, x is representing the number of donuts. And on the y-axis, that represents the price per donut. And the label there is dollars per donut, or dollars per unit if you don't want to think about donuts. Okay? And the graph that we were given on the graphing calculator is this diagonal straight line that crosses the y-axis at 1.4, crosses the x-axis at 7. So then we can mark the rest of these values. 7, 6, 5, 4, 3, 2, 1. And what this, so P equals 1.4 minus 0.2x. Now, what this graph is this is a graph that we might call the consumer demand curve. And the consumer demand curve relates the price per unit, or the price per donut in this case, to the number of units, or in this case the number of donuts, that the consumer is willing to purchase. So the consumer demand curve relates the price per unit to the number of units that the consumer is willing to purchase. Okay. Now, what we saw in the video was when our customer went into the D-Cube donut shop, she saw the original price of $1.40 per donut. And so when the price was $1.40, the X value that corresponds to that Y value of 1.4, the X value is 0. So she was not willing to buy any donuts at all. On the other hand, when the price was set at $1, when she walked into the donut shop, she said, you know what, I'll buy 2 donuts. And the reason that that happens is, if we look at our graph and walk across and then down, the number of donuts that she's willing to purchase is 2 if the price is $1. Okay? Okay, so this kind of makes sense, right? The higher the price, the less donuts the consumer is willing to purchase, or the less units that the consumer is willing to purchase. So as this price per unit is higher, we're going to hit the graph earlier and we're going to have a smaller X value. So the higher the price per unit, the smaller the number of units the consumer is willing to purchase. Because of that, anytime we have a consumer demand curve, our graph will always be a decreasing function. The lower the price, the more donuts she's willing to buy. Okay. So our consumer demand curve is a decreasing function. Okay, so let's ask a question. Suppose that the price per donut is set at 80 cents. How many donuts is the customer willing to buy? Okay, so we have this information. We know that the price per donut is equal to 1.4 minus 0.2x. P is our price per donut, and X is the number of donuts. So we're told that our price per donut is being set at 80 cents. Another way to write that in dollars is 0.80. So $0.8 is going to be equal to 1.4 minus 0.2x. And our goal is to solve for x. So how do I solve for x? Well, I can subtract 1.4 from both sides. And so on the left side, I end up with negative 0.6. And on the right side, I have negative 0.2x. And then I can divide both sides by negative 0.2. And on the right side, it gives me an x. And on the left side, I have a 3. And so what that tells me is if the price is set at 80 cents per donut, then the consumer will purchase 3 donuts. Okay, so algebraically the way we figure that out is we plug in our price per donut and we solve for x. Graphically, let's go back over to our graphing calculator. If you'd like some donut, you can help yourself. Okay. Graphically, if I want to figure out when the y value is 0.8, what is the x value, I cannot use the trace function because the trace function, we have to type in the x value and then get an output that's a y value. But here we're kind of doing the opposite. We're given a y value when we want to find the x. So one way to do this is to put in a second y value, in this case 0.8 and graph both functions at the same time. And what we're going to do is find the intersection of these two graphs. And the way I do that is I hit second, and then calc, and I go down to number 5, which is intersect. Okay. It's going to ask me which curves. So, yep, the first curve is where the cursor is now. I hit enter. Okay, now the cursor's on the second curve. I hit enter again. And then I move the cursor kind of close to that intersection point. I hit enter. It says when y equals 0.8, our x value is 3. So graphically, I can find that number of donuts by graphing a line for the y value we want and seeing where it intersects our graph. Okay, so from the consumer's perspective in this interaction, the consumer is saying, the lower the price, the more donuts I'm willing to purchase. Now, you might have also noticed that our customer walked in at one point and the donuts were being offered for free. And that's where that's where this intersection point is here. When the price is $0 per donut, when we walk across, our graph hits at an x value of 7. That says that the consumer says, you know what, even if they're free, I'm not interested in purchasing more than 7 donuts. You know, too much of a good thing is bad for your belly. Okay, so this is the consumer demand curve. We also want to talk about the perspective of the producer. And to talk about the producer, we talk about the producer supply curve. So for our producer's perspective, a donut shop owner is willing to supply X donuts if the price per donut is set at P equals 0.07 x squared plus 0.17 dollars per donut. Okay. So let's graph this function. This is going to be our producer supply curve, and let's see what it looks like. So we'll go back to our y equals. I'm going to go ahead and clear out the second one, and we're going to need that first function again, so I'm just going to unselect it for now. And our producer supply function is 0.07 x squared plus 0.17. And let's see what happens when we graph. Okay, so we have our function. If we want to, we can change our zoom so that we have a zoom fit for this particular function, and let's see what happens. Cool. So here is our consumer supply curve. We're going to draw this up on the board. All right, so when I draw this, my x-axis is representing number of donuts, or in general, number of units, and our y-axis represents the price per donut. And the curve that we have looks something like this. And this is P equals 0.07 x squared plus 0.17. And along the x-axis, we have some marks, 1, 2, 3, 4, 5, 6, 7, etc. On the y-axis is our price per donut. Okay. And this curve that we have drawn here is our producer supply curve. And the producer supply curve relates the price per donut to the number of donuts that the supplier or the producer is willing to make at that price. So the producer supply curve relates the price per donut to the number of donuts the supplier is willing to produce at that price. Okay. And what you'll notice about this graph is that this graph is an increasing function. And that makes sense because from the perspective of the supplier, if the supplier is only going to make 17 cents, is only going to be paid 17 cents per donut, they're going to say, I'm not even going to cover my costs at that price. So I'm not going to produce any donuts. But if the donuts are selling for $1.92, well, if the donuts are selling for that price, then the producer's going to say, heck yeah, man, I'm gonna produce these donuts all day for that price because I'm making a lot of money per donut. So the higher the price per donut, the larger the corresponding X value. So our producer supply curve is always going to be an increasing function. Okay, so now we've talked about the producer supply curve and the consumer demand curve. And when we're talking about an economy, we want to know at what point does supply meet demand. So what we want to do is we want to look at the intersection of these two graphs. So when supply meets demand, we have something called the equilibrium point. Okay, so to talk about this equilibrium point, we're going to go back over to the graphing calculator, and we're going to graph both the consumer demand curve and the producer supply curve in the same window. So here I'm going to hit enter, and now I have both of the functions activated. And I'm going to go ahead and hit graph. And what I see is I have my demand function, and then I have my supply function. Okay. Now let's maybe change this window a little bit. Let's make our x minimum 0. I'm sorry, our y minimum 0. And we'll graph again and see what happens. And then I'm going to cut it off here at about 2 because the rest of that I don't really care about. So I'm going to change my window to a y maximum of 2. Okay, so we have our demand function and our supply function. And this point where they intersect, that's our equilibrium point. That's the point where supply meets demand. So the way that I can find this graphically is I can hit second calc, and then on this list of choices, I want to look at number 5, which is intersect. And it asks me, which curves do I want to look at? Yep, the first curve is that straight line. I hit enter. Is this my second curve? Yep, I hit enter. And then it asks me for a guess. So I'm going to use my arrow button to move my cursor pretty close to the intersection. It doesn't have to be right on top, and that's fine. I hit enter, and it tells me that the intersection point is an x value of 3 and a y value of 0.8. So let's go draw this over on the board so we can add some labels onto it. Okay, so on the x-axis we have number of donuts. On the y-axis we have the price per donut. We have our consumer demand function. So shorten that to demand curve. And then we have, let's see, our supply function, which is an increasing function. And so this is our supply curve. And their intersection point, according to our graphing calculator, we have an x value of 3 and and a y value of 0.8. So we call this point right here our equilibrium point. This 3 is the number of donuts, and so our equilibrium quantity is 3 for 3 donuts. And this 0.8, that's our price per donut, and so that's our equilibrium price. So our equilibrium price is $0.8, or you could say that as 80 cents. Okay. If I label it as an ordered pair, then my equilibrium point is 3, 0.8. Okay. So what this says is, if the price per donut is set at 80 cents per donut, then the supplier is willing to supply 3 donuts, and the consumer is willing to purchase 3 donuts. So we have exactly the number of donuts produced that the demand is for those donuts. And so this is our equilibrium point. Okay, now we haven't actually talked about any calculus yet, and you might be wondering, Diane, what is this? This is not calculus. And some of you may have talked about this in your finite math class. We haven't gotten to the calculus yet. The calculus comes in when we talk about consumer surplus and producer surplus, and those are the next 2 sections that we're going to talk about. Thanks.